Hi everyone, today let's try to solve some problems from the 2024 AMC 10A as quickly and as efficiently as possible. So, let's start with problem 1. The problem reads, what is the value of 9901 times 101 minus 99 times 10101? So, let's first notice that 9901 times 101, since both of these have a 1, the unit digit is going to be a 1. And 99 times 10101, since 9 times 1 is 9, this is going to have a unit digit of 9. So the units digit of this subtract this will be equal to 2. So that leaves us with the answer choices A or D. Now let's take this thing modulo 3. Modulo 3 basically means the remainder 1 is divided by 3. Since this is a 99, the remainder when the second product will be divided by 3 is just 0. This is congruent to 1 modulo 3. This is congruent to 2 modulo 3, which gives us 2 modulo 3 as a total. So 2 minus 0 modulo 3 is going to be equal to 2 modulo 3. Therefore, it must be congruent to 2 modulo 3, so the answer choice must be A, since D is congruent to 1, not 2 modulo 3. So the answer number 1 is A. And now let's solve number 2. A model is used to estimate the time it will take to hike to the top of the mountain on a trail is of the form T is equal to AL plus BG, where A and B are constants, T is the time in minutes, L is the length of the trail in miles, and G is the gain in feet. The model estimates that it will take 69 minutes to hike to the top if the trail is 1.5 miles long and ascends 800 feet, as well as if a trail is 1.2 miles long and ascends 1,100 feet. How many minutes does the model estimate it will take to hike to the top of the trail if it is 4.2 miles long and ascends 4,000 feet? Okay, so T is the amount of time in minutes. So let's write 69 is equal to A times what was the first value they gave us? They gave us 1.5. So 1.5 plus B times the gain in feet. So B times 800. But it's also equal to 69 is also equal to, if it's 1.2 miles long, times A plus it said 1,100 feet, right? So 1,100 B. So therefore, since we see this 1.5, this 1.2, that's not very good. So let's try to find a common divisor of these two. And it looks like 6 is available because this times 4 is equal to 6 and this times 5 is equal to 6. So 69 times 4 is equal to 6A plus 3,200B. And then this one would be 69 times 5 is equal to 6A plus 5,500B. And subtracting these two, 69 will be equal to 2,300B, so B will be equal to 3 over 100B. 3 over 100, just 3 over 100, because 69 over 2,300. And therefore, we can find A now. If we just, 69 is equal to 1.5A plus 3 over 100 times 800. 24, so that's going to give us minus 24, 545 is equal to 1.5a. And so if we divide 45 by 1.5, that just gives us 450 over 15, which is equal to 30. And now, since we know both a and b, we just plug it in. So t is equal to 30 L plus 3 over 100 G. And since it ascends 4.2, since it's 4.2 miles long and ascends 4,000 feet, we plug that in. That gives us 126. And this one gives us 40 times 3, which is 120. And if we add those two, it's going to give us 246, which is answer choice B. So number 2 is B. Now let's solve number 3. Problem 3. What is the sum of the digits of the smallest prime that can be written as the sum of 5 distinct primes? So let's just list out all the primes. 3, 2, 3, 5, 7, 11, 13. And if we sum these three, then they give us 17. That's going to give us something even. And we don't like even, because even is never a prime unless it's 2. So let's start with these three. If we sum these, they give us 15 plus 24, which is 39. Now let's write 17. If you take away 13 and put 17 instead, that would give us 43, I think. So because 3 plus 5 is 8, 8 plus 7 is 15, 15 plus 11 is 26, 26 plus 17 is equal to 43. So 43, 4 plus 3 is equal to 7, which is answer choice B again. And now let's try number 4. The number of 2024 is written as the sum of not necessarily distinct two-digit numbers. What is the least number of two-digit numbers needed to write the sum? Okay, so we can just like spam 99 until there's a remainder last one. Okay, so 99a plus r will be equal to 2024, and so we just divide 2024 by 99. This is 2, 198. That gives us to 44. So it's going to give us 20 remainder of 44. So just let it be 20 times 99 plus 44. So there's one number here, 20 here. So 20 plus 1 is equal to 21, which is answer choice B. Okay, let's solve number 5 now. And the problem reads, what is the least value of n such that n factorial is a multiple of 2024? So let's first prime factorize 2024. This is equal to 245 squared, which is 225, minus 1, which is equal to 46 times 44. Now, this will be equal to 2 times 23 times 2 squared times 11. The largest prime is 23, so we know that the largest factorial will be equal to 23. 23 is our answer, which is answer choice D. Okay, now let's do problem 6. So problem 6. What is the minimum number of successive swaps of adjacent letters in the string A, B, C, D, E, F that are needed to change the string to F, E, D, C, B, A? So A, B, C, D, E, F. To get this here, we need at least 5. To get this here, we need 4. To get this there, we need 3, and so on until we need 1. So it's just 1 plus 2 plus all the way to 5, which is 15, and that's answer choice D. And that's done. Okay. The problem 7 reads, the product of 3 integers is 60. What is the least possible sum of the 3 integers? Let's just prime factorize 60. That's going to give us 2 squared times 3 times 5. Okay, so let's try some stuff. If we want them all to be positive, it could be 4 plus 3 plus 5, which is equal to 12. But the thing is, we can have negative too. So let's try to find something that can give us the smallest possible. Negative 4, negative 3, 5 doesn't work because that's negative. So let's try another one. Let's try 10, negative 6, negative 1. Give us 3. And I don't think we can do any better than that. So the answer must be 3, which is B. For problem 7. For problem 8 now. Amy, Bomani, Charlie, and Daria work in a chocolate factory. On Monday, Amy, Bomani, and Charlie start working at 1 p.m. and were able to pack 4, 3, and 3 packages respectively every 3 minutes. At some time later, Daria joined the group and Daria was able to pack 5 packages every 4 minutes. Together, they finished packing 450 packages at exactly 2:45 p.m. At what time did Daria join the group? Okay, so let's first find the amount of packages Amy, Bomani, and Charlie could do from 1 to 2:45. So since they were able to package 4, 3, and 3 packages respectively every 3 minutes, they had in total were able to do 10 packages every 3 minutes. From 1 to 2:45, that's going to give us 1 hour and 45 minutes, which is 105 minutes. And so if we divide 105 by 3, that gives us a total of 35 times, and then we multiply it by 10, which is 350. So there's 350 packages only by Amy, Bomani, and Charlie. And now we do 450 minus 350, which is 100 packages that Daria needed to pack. And since Daria was able to package 5 packages every 4 minutes, then 100 we just multiply by 20, and we just multiply by 20, which is 80 minutes. And so we subtract 80 minutes from 2:45, which gives us 2 o'clock minus 35 minutes. And that is going to give us 1:25, which is answer choice A. Now let's try problem 9. In how many ways can 6 juniors and 6 seniors form 3 disjoint teams of 4 people so that each team has 2 juniors and 2 seniors? So we have 6 juniors, 6 seniors, and they form 3 disjoint teams of 4 people. So let's call them team A, B, and C. Although they aren't like they don't necessarily need to be called A, B, and C. They can, if we swap them around, it's completely fine. So 3 disjoint teams of 4 people such that you have 2 juniors. So 2 junior, 2 senior, 2 junior, 2 senior, 2 junior, 2 senior. Okay, so there's going to be 6 choose 2 ways to choose a junior, times 4 choose 2 to choose the next junior, times 2 choose 2 to choose the last junior, and similarly it's the same thing for the other one. So this gives us 15 times 6 times 1, which is 90 squared, which is 8100. But as I said before, we don't need to label this exactly A or B. We can swap them around. So we also need to divide for rotations. So 8100, we have to divide by 3 factorial, which is equal to 8100 divided by 6, and that's going to give us 1, so 621, and that's going to be 1350, which is answer choice B. Okay, consider the following operation. Given a positive integer n, if n is a multiple of 3, then you replace n by n over 3. If n is not a multiple of 3, then you replace n by n plus 10. For example, beginning with n equals 4, this procedure gives 4 to 14 and so on. Suppose you start with n equals 100. What value results if you perform this operation exactly 100 times? So, we start with 100, right? And since this is not divisible by 3, we go to 110, 120, divisible by 3, so we've dropped down to 40, 50, 60, down, and that gives us 20 plus 10, 30, down, which gives us 10. And then 10, you go to 20, and then you go to 30, and then you drop back down to 10. And this just keeps on repeating after here. So this is what happens. The operation is once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times. So if the operation is occurring modulo 3, if it's occurring 2 modulo 3, then it'll be 10. If it's 3 modulo congruent to 3, it's going to be 20. And if it's congruent to 1 modulo 3, then it's going to be 30. So the answer should be 30. And 30 is answer choice C, so the answer is C. Now let's do problem 11. Okay, how many ordered pairs of integers m, comma, n satisfy root n squared minus 49 is equal to m? Now if you square both sides, then that gives us n squared minus 49 is equal to m squared. And n squared minus m squared is equal to 49. But remember that n squared must be greater than or equal to 49. Okay, so just remember that. And we can factor this as n plus m times n minus m is equal to 49. Also remember that m has to be greater than 0. So 49 is equal to 7 squared, so we can let this be 149 or 7 and 7. We could also try negative 49, negative 1, and etc. And that would give us negative 7 and negative 7 to try too. This leads to n is equal to 25, m is equal to 1. M is equal to 24. And then this one will be equal to 7 plus 7. So this would be n is equal to 7, m is equal to 0. And this one would give us n is equal to negative 25, m is equal to negative 24. But this doesn't work because these are negative. And this would give us n is equal to negative 7, m is equal to 0. And this one works, and this one works. So we have three pairs, and the answer is therefore, I think, C. Wait, but we realized that also for this one, m could also be equal to 24. So actually this one works too. And so the answer is therefore 4, which is answer choice D. Now let's do problem 12. Zelda played the Adventures of Math game on August 1 and scored 1,700 points. She continued to play daily over the next 5 days. The bar chart shows the daily change in her score compared to the day before. What was Zelda's average score in points over the 6 days? So she started with 1,700 on August 1st, and she changes 5 times. So the first time it's 1780, then subtract 90 it's 1690, minus 10 again it's 1680, plus 60 it's 1740, and then lastly subtracted by 40 it's 1700. Now let's look at these. So let's just add 1700 in the end and take the average of the rest, because then we can just like simplify our calculations. And that just gives us 0, 80, negative 10, negative 20, 40, and 0. And just add all of these, which gives us 120 minus 30, which is 90. And then we divide by how many are there? There's 6, which gives us 15. So 1700 plus 15 is equal to 1715, which is answer choice E. Okay, problem 13 now. Two transformations are said to commute if applying the first followed by the second gives the same result as applying the second followed by the first. And we are given 4 transformations and we need to find how many commute. So let's let the first transformation T1 equal transition 2 units to the right. So that gives us x plus 2 comma y. T2 would be equal to 90-degree counterclockwise rotation about the origin, which is negative x comma y. Oops. I meant negative y comma x. And T3 would be equal to reflection across the x-axis, which leaves x constant, so x comma negative y. And T4 would be equal to dilation center at the origin with scale factor 2, 2x comma 2y. Okay, so let's think about it. If we apply T1, T2, we can easily see that this does not commute, because this is a slide and then a reflection across the x-axis. And the rotation around 90 degrees. It's not going to be the same. For example, if I had a dot here, I move it two more, and then I rotate it 90 degrees. That's clockwise, but counterclockwise is the same. And then rather than doing here and then moving here, that's different. So this is not going to work. T1 with T3. A reflection across the x-axis. Let's try this. So x plus 2 comma y. This is applying T1, T3, and then we move it around, which gives x plus 2 comma negative y. Whereas if we did it the other way around, that gives us x comma negative y, and then that gives us x plus 2 comma negative y, so this does work. Okay, now let's try T1, T4. This is going to be different. For example, if I started one here, and then I moved it this way, and then doubled it over, then that'd be different from doubling this and then moving it over too. So this does not work. And now let's try T2, T3. First way, it's going to give us negative y comma x, and then since we can just reflect it, which gives us negative x comma negative y comma negative x. But applying it T3 to T2, that gives us x comma negative y, and then we flip it around, so it's going to be y comma x. So that does not work, unfortunately, and this does not work. Now let's try T2 and T4. So that's negative y comma x and 2x comma 2y. And if we try this, then that gives us negative 2y comma 2x. And whereas if we did it the other way around, it's going to be 2x comma 2y. And then we flip it around, that's going to give us negative 2y comma 2x. So this does work. Now let's try T3 and T4. So far we have 2. So it's going to give us x comma negative y. This is T3, T4, x comma negative y, or it could be 2x comma 2y. If we did it the first time, they'd give us 2x comma negative 2y. If we did it the other way around, then that'd give us 2x comma negative 2y 2. So this works, and we have 3 that work. So the answer is answer choice C, 3. And now let's do problem 14. One side of an equilateral triangle of height 24 lies on line L. The circle of radius 13 is tangent to line L and is externally tangent to the triangle. The area of the region exterior to the triangle and the circle and bounded by the triangle, the circle, and the line can be written as a root b minus c pi, where a, b, and c are positive integers and b is not divisible by the square of any prime. What is a plus b plus c? Okay, let's try this problem. So problem 14. So let's first draw the line L. Very nice line. Call it L. And then we have an equilateral triangle, so here's our equilateral triangle. So and then it has a height 24, so let's draw that down. A circle or radius 12 is tangent to line L and externally tangent to this triangle. So it's going to look like this. It's going to be tangent to both of them. Slightly over. And we want to find the region, the area of this part. The black part over here. So let's first connect the center with some lines, because that's always the best thing to do when we have circles. And let this be 90 degrees, and this gives us 90 degrees too. Since this is 12 and this is 12, let's draw this line down here too. Okay, so something we know is that this angle is 60 degrees, right? Let me just mark that better. So this is going to be 60 degrees. And then that means that, let me just draw this kite. If we know that this is going to be 60 degrees, and that means that this entire red part is going to be 120 degrees. Then we divide that by 2, since these two angles are the same. So this is also going to be 60 degrees. So we know that this angle is also going to be 60 degrees. And therefore, we know that by 30, 60, 90 triangle, this line down here, this green part, that's going to be 12 over root 3. And the area of this part will be 12 over root 3 times 12, which is 144 over root 3. Let me write that, 144 over root 3. Now we just need to subtract the area of this sector. Since we know that this part is 60 degrees, that means that this part must be 30 degrees, and this must also be 30 degrees, so this is a total 60 degree sector. So 60 degrees is 1/6 of the circle, so 1/6 times 144 pi would give us 24 pi. And now our answer is 144 over root 3 minus 24 pi, but we want to write in a root b minus c pi. So a root b, it's going to be 144 root 3 over 3. Cancel, which gives 48 root 3. 48 root 3 minus 24 pi. And that just gives us a grand total of 72 plus 3, which is 75, and which is answer choice D. Okay, now let's do problem 15. Okay, problem 15. So m plus 113 and m plus 3773 are both perfect squares. What's the unit digit of m? Okay, so let's let this be equal to p squared. Let this be equal to q squared. If I subtract these, then q squared minus p squared would be equal to 3,773 minus 1213, which gives 0.652560. So we need to maximize m, which also means maximizing q. And from, remember problem 7 about the n squared and n squared minus 49, we can factor this again. Q plus p, q minus p is equal to 2560, which is also equal to 1280 times 2. Notice that if we let this be equal to 1 and this equal to 2560, this will give us decimals, which is not what we want. So we want them to have the same purity. And 2 is the smallest possible purity, so we can just let this be equal to 2, and this is equal to 1280. And adding these two gives us that 2q is equal to 1282, and q is equal to 641. Similarly, if we subtract them, p is equal to 639. So now what we need to do is just do 641 squared minus 3773 is equal to m. And this is going to have a unit digit 1, this is a unit digit 3, so the unit digit of m will be 8, and our answer is going to be E. Okay, and that's it for today. Thank you so much for watching, and I hope you learned something. If you want me to solve any problems, please leave in the comments. If you learned something, also please consider supporting me by liking and subscribing. Thank you so much.